we are enjoying. I know you're enjoying this. This is beautiful, isn't it? It's beautiful. You need to have the charts to keep it in your heads. Okay, so now we're doing the reactions of ethers. This is very important. This is very nice. So reactions of ethers, you only have one thing to know. It's the reaction of ether with a hydrogen halide. Okay? So ethers react with only one thing. One. We saw how they are made two ways. Williamson synthesis, where you first convert your alcohol to an alkoxide, then you add an alkyl halide. That's so easy. Then the other one was the alcohol sulfuric acid method, where you add sulfuric acid and you heat to a temperature which is slightly lower than that which you do when you do dehydration, which is converting an alcohol to an alkene. Now, in the reactions of ethers, the reactions that ethers do themselves, in here we were preparing or making ethers. Now we are seeing how they react, they themselves. Okay, remember that when you do Williamson synthesis, you make an unsymmetric ether. When you do the other one, you make a symmetric ether. Don't forget that. Don't forget it. I know you won't. Now let's talk about reactions of ethers themselves. How do ethers react? Well, they do what we call acidic cleavage, okay? Which is you just add an acid, which is for our acid, we are just adding the hydrogen halides, okay? Hydrogen and a group 7. If you add hydrogen and a group 7 to an ether, it is going to break. It's going to break. So you have an ether. Just put it as R or then R prime, okay? This is an ether. Carbons here, an oxygen and carbons there. An ether is so simple, right? It's just an oxygen linking them. So what happens is if I come and add an HX, it's going to break. Now, what you must know is when it breaks, oxygen never goes with the bigger guy. Oxygen never goes with the guy that has more carbons. Okay, never. So it's like this. Never, it never does that. So it's like I have, let's put something like, okay, something like this. So this is what we have, okay? You can put this as a CH3 if you want. Then put this as a CH3 if you want. Then put an H, whatever. Then this one, we can have it as a C with two H's, of course. And then it's connected to a CH3, right? Which is a series 3 H's. Now, look here. You want to know that if I add, this is an ether. If I add HBr, then what's going to happen here? Okay, so this guy, this HBr is added to three things. We've seen it being put at three things. One, alkenes, right? If you have HBr, you can add it to an alkene, like hydrogen halide, okay? For alkenes, we can say alkenes by plus HCl or HBr. We know that the double bond in alkenes will break. And according to Markovnikov, hydrogen will go to the carbon with more hydrogens and X will go to the other one. Then we've also seen that you can add HX to alcohols in halogenation. Yes, you can add group 7 to alcohols. We saw that. But we saw that in alcohols, it is not like in alkene where both the H and the X are going to go. No. In alcohols, when you add HX, the OH goes and the X comes to replace it. So, and we said we usually like to do it for tertiary alcohols, although you can do it for primary and for secondary as well. But now we are having it being added to ethers, which is the last other thing that you can add. So you can add HX to alcohol, the OH goes and the X goes on its place, right? If you add HX to an alkene, you use Markovnikov, right? But now we are adding it to an ether. Then what happens when you add it to an ether? When you add it to an ether, what happens is it breaks it. It breaks it, people. It breaks the ether. Where? Where does it break it? Where does it break it? Here or here? That's the question. Well, all never goes with the guy connected to more carbons. So let's talk about this carbon here. What type of a carbon is it? It's a secondary guy because it's connected to two other carbons. What about this one? This one is a primary. It's connected to one other carbon. So where will the O go? O will always go with the lower guy, which is the primary. So here it is going to go with the primary. So it's going to break here. And what are you going to have? You're going to have this come as a CH. Then we have it as this is a CH3. Let me change the color so you can see. So this is a CH3. Then here we have a CH3. Then the bond which has gone here is now going to be replaced by a Br. Oxygen never, ever, oxygen never goes with the more let's say, complicated carbon or whatever, the higher carbon in the list. So it's the tertiary. If it's secondary carbon, we know he's not going to go with the O if the primary one is there. So the primary will go with the O, and we end up having this guy being an alcohol. So it's going to be like CH3 and then H, then H, then here it's now an OH. So that's what happens. Okay, remember, this was an O, so the H will come and it becomes an OH. Then this Br will come to this other carbon. That is what happens in acidic cleavage. Should I put another one? That's the only reaction of ethers. Come on, I know you can remember this. Okay, we keep going. Let me show you. Don't be quick to break. Don't be quick. Continue watching because there's something I want to show you at the end though. Now, what about if I have, like we say, a carbon connected to just hydrogens? And okay, let's make it nicer. Let's put what? A secondary and a tertiary, of course. So we could have here a secondary, which is a carbon connected to two other carbons, okay? And then this is a hydrogen, right? Then it's connected to the O, then this is connected to a carbon, which is connected to just carbons, okay? So now I ask you, where will it break? Of course, we say the oxygen can't go with this because this guy is a tertiary carbon. This one is a secondary carbon. So obviously it will break here, okay? And then what you're going to have is you're going to have a CH3 and a CH3 and an H. And this now becomes an OH, then plus. Remember, oxygen for ether reactions, put that. Oxygen never goes with the carbon with more carbons, okay? Never. Oxygen goes with the carbon with less carbons. So this is now going to be now he with more carbons, this guy with more carbons. He is now just going to remain and be, this is, let's say we have added, we had this and we have added HCl, okay? That is when it's going to break. And now we'll end up having this, and here comes the Cl, okay? We've added HCl. Remember, we add H and a group 7. Don't forget that, okay? And that's acidic cleavage. Now I'll put the last case of acidic cleavage. It's still acidic cleavage. What happens if we have it like this? Let's put, there's an exception which I need you to know and remember is what happens if we have something like this and then O, then connected to carbons and whatever, CH3 or CH2, CH3, we don't, yeah? Like this. Where will it break if we add an HBr? Where will it break? What will we get? Well, what you must remember is when you have this guy, a benzene with an O, he always goes with the oxygen. That's only for this guy, this benzene. So normally we would say, oh, the carbon doesn't go with the carbon with more carbons, but we don't care. Once you see a benzene, it always will go with the O. So for benzene, remember, O always goes with the carbon with less carbons unless you have a benzene. O will always go with the benzene. So it's like this. So that means you have your benzene become an OH, okay? That's what happens. How isn't this nice? I know it's nice. You like it. Then this is going to be, so it's going to form this. This is what we're going to form, this OH plus here is where the Br will now go. So remember that. That is the secret. Okay. And this is a Br. Okay. Remember the secret. Don't forget it. Don't forget. Come on. I know you won't. So remember we said the O goes with the whatever carbon. O always goes with the carbon bonded to less carbons unless you meet this guy. Okay? I know you have mastered it. And that is it so far. Meet you in the next one. Goodbye for now.